Hey, this is Presh Talwalkar, and you're watching Mind Your Decisions. You may remember me from such videos as 6 divided by 2, parentheses 1 plus 2, or 9 minus 3 divided by 1/3 plus 1. The first video has over 9 million views, and the next video has over 7 million views. Right now, the internet is going crazy over another problem. So it's time for the order of operations to save the day. The problem is 60 divided by 5, parentheses 7 minus 5. What is this equal to? We'll solve this using the order of operations. This is commonly referred to as PEMDAS or BODMAS. It refers to the precedence of operations. We first have parentheses brackets, then exponents orders, then multiplication division, and finally addition subtraction. If you have multiple operations of the same precedence, you should evaluate them from left to right. So in this expression, we have some parentheses. So we should evaluate 7 minus 5 first. This is a non-controversial part of the question, and this is equal to 2. The argument is about what to do next. According to the order of operations, we should evaluate multiplication and division with equal precedence going from left to right. Therefore, we should evaluate 60 divided by 5 first. This will be equal to 12. Finally, we evaluate 12 times 2, and that gives us the correct answer of 24. This is without a doubt the correct answer according to the modern interpretation of the order of operations. But let's time travel for a bit. Well, historically, this division symbol had a special meaning when you wrote it in text. So let me go over this interpretation. We would still evaluate the parentheses first. 7 minus 5 is equal to 2. The question is what to do next. The special rule about this division symbol is that you would evaluate everything on the left and divide it by everything on the right. So if you have x divided by 2y, that would be equal to x divided by parentheses 2 times y. So if we use this special rule, we would then need to take 60 and divide it by 5 times 2. So we take 60 on the left, 5 times 2 on the right, and we would form a fraction as follows. We then would evaluate 5 times 2 as being equal to 10, and then we would take 60 divided by 10 and get to the answer of 6. This is one way that people do interpret this question. So some people say the answer is 6, other people say it's 24. So some people would argue the expression is ambiguously written, so there is no correct answer. It is analogous to a poorly written sentence. For example, take the sentence, "I saw the man with binoculars." Does that mean you used binoculars to see the man? Or does it mean you see a person, a man, who had binoculars in his possession? It's an ambiguous sentence, and you could say there's no correct way to interpret this sentence. There is a point to be made here. Just as we should write precise sentences, we should write precise mathematical expressions. However, in practice, we have to resolve ambiguity. Just as courts interpret and make rulings on ambiguous laws, calculators parse and evaluate seemingly ambiguous expressions, like 60 divided by 5, parentheses 7 minus 5. A calculator will not tell you, oh, the expression is ambiguously written, there is no correct answer. It actually will evaluate this expression. So what do calculators do? How do they evaluate 60 divided by 5, parentheses 7 minus 5? The calculator will interpret it using its programmed order of operations, its own precedence of how to evaluate different operators. One way to visualize the process is a binary expression tree. So imagine you put this into a calculator. it's going to make a guess about how to interpret this. And one way a calculator will interpret this is just as I explained using PEMDAS, by putting a parenthesis between the 60 and the 5. We can then visualize the binary expression tree as follows. We have the operation of 60 divided by 5, that's one subtree. We then have 7 minus 5, that's another subtree. And finally, we take these two evaluations and we multiply them together. And if you do that, you get to the answer of 24, which is what PEMDAS or BODMAS says the answer should be. The other people would say that you should put a parenthesis over here after the division sign. The binary tree for this expression will look different. At the very bottom, we have 7 minus 5. We then take 5 multiplied by this result. We then take 60 and divide it by this result. So we have a completely different binary expression tree. This binary expression tree will evaluate to 6. So this is what the debate is about. Is the answer 24 or is it 6? Which binary expression tree do you think is correct for the above expression? Well, we can actually try this on several calculators. Let's put it into Google, for example. 60 divided by 5 parentheses 7 minus 5. How does Google interpret this? Well, if we input this as a search, we get the Google calculator result of 24. And if you zoom in and look at this expression, you'll see it parses it exactly as the binary tree on the left. We do 60 divided by 5, and then we multiply it by the quantity 7 minus 5, and that's what gets us to the answer of 24. Google is not the only calculator that'll do this. Many calculators, in fact, will give you the answer of 24. One such calculator is the Android Calculator app. If you put in 60 divided by 5 parentheses 7 minus 5, you'll also get the answer of 24. I've also tried this on many other calculators. You'll also get the answer of 24. But I wouldn't be surprised if some calculator did give the answer of 6 if it evaluated it according to the other binary tree. But from what I've seen, almost every calculator gives the answer 24. So in summary, 24 is the unambiguous answer according to the modern interpretation of PEMDAS or BODMAS, and many calculators also evaluate the expression this way. So I would say 24 is the correct answer to this expression. I love that people are passionate about mathematics, and this seemingly simple, trivial problem actually led us to understanding the order of operations. It led us to a little bit of math history and typesetting, and we got to explore binary expression trees. It's just amazing, and I'm sure the people who are arguing about this problem will make great contributions to mathematics and society because they have such passion about these seemingly trivial expressions. Thanks for watching this video. These math videos, which can be watched for free, inspire and build confidence for people around the world, and they already have over 100 million views. Let's share the beauty of mathematics. With your help, we can math the world a better place. Please subscribe for free to get the newest videos, watch and share all of Mind Your Decisions videos, and if you so choose, you can check out my books which are linked in the video description, and you can support me on Patreon to earn exclusive rewards. Thanks for watching, and thanks for your support.